Welcome to Maths Companion. I am Ramesh. How are you all? Do you remember what we have learned in the last video? In the last video, we have learned how to find the sum of terms of an arithmetic sequence. We have learned sum of first and natural numbers is n into n plus 1 by 2. We have also learned sum of first and even numbers is n into n plus 1. Then we have learned sum of first and odd numbers is n square. And after that we have learned sum of n terms of any arithmetic sequence is n by 2 into first term plus last term. Then we have learned the properties of sum of n terms of an arithmetic sequence. We have learned the sum of the first n terms of an arithmetic sequence is of the form an square plus bn, where a and b are fixed numbers. The coefficient of n square is half the common difference, and we have also learned that sum of the coefficients of n square and n is the first term. Then there were three homeworks. Let us check the answers. The first one, find the sum of the first 25 terms of each of the arithmetic sequences below. Let us take one by one. The first one is 11, 22, 33, etc. We have to find sum of first 25 terms. Here the first term is 11 and we know the common difference is also 11. The last term of the sequence is 25th term. We have to find sum of 25 terms only. So let us find 25th term, that is dn plus f minus d. Replacing the values, we get 11 into 25 plus 11 minus 11. 11 minus 11 is 0, so we get 11 into 25 and that is equal to 275. That is, the 25th term or last term is 275. Now let us find the sum. Sum is n by 2 into first term plus last term. So we can write 25 by 2 into first term is 11 and last term is 275. So we can write it as 25 by 2 into 286. 2 and 286 can be simplified and we can write 25 into 143. Multiplying, we get 3575. That is, sum of 25 terms of this sequence is 3575. Second one, 12, 23, 34, etc. First term is 12, common difference is 11. Now the 25th term is 11 into 25 plus 12 minus 11. 12 minus 11 is 1. So we can write 11 into 25 plus 1. That is 275 plus 1 or 276. Now the sum is n by 2 into first term plus last term. That is 25 by 2 into 12 plus 276. 12 plus 276 is 288. So we can write it as 25 by 2 into 288. 2 and 288 can be simplified and we can write 25 into 144. Multiplying, we will get 3600. That is, sum of 25 terms of the sequence is 3600. The third part, 21, 32, 43, etc. Here also we have to find sum of first 25 terms. First term is 21, common difference is 11 and 25th term is dn plus f minus d, or 11 into 25 plus 21 minus 11. We can write it as 11 into 25 plus 10 or 275 plus 10, that is equal to 285. Now the sum is n by 2 into first term plus last term, or 25 by 2 into 21 plus 285, that is 25 by 2 into 306. 2 and 306 can be simplified and we can write it as 25 into 153. Multiplying, we will get 3825. Fourth part, 19, 28, 37, etc. First term is 19, common difference is 9 and 25th term is dn plus f minus d, or 9 into 25 plus 19 minus 9. This can be written as 9 into 25 plus 10. That is 225 plus 10, or that is equal to 235. Now the sum is n by 2 into first term plus last term. That is 25 by 2 into 19 plus 235. 19 plus 235 is 254. So we can write 25 by 2 into 254. 2 and 254 can be simplified, and we can write it as 25 into 127. And multiplying, we will get 3175. And the fifth part, 1, 6, 11, etc. Here the first term is 1, common difference is 5. Now we have to find 25th term. That is 5 into 25 plus 1 minus 5. 1 minus 5 is minus 4. So we can write 5 into 25 minus 4. 5 into 25 is 125. So we can write 125 minus 4, and that's equal to 121. Now the sum is n by 2 into first term plus last term. That is 25 by 2 into 1 plus 121. And that is equal to 25 by 2 into 122. 2 and 122 can be simplified, and we can write it as 25 into 61. Multiplying, we will get 1525. That is, sum of 25 terms of this sequence is 1525. Now the second problem, what is the difference between the sum of the first 20 terms and the next 20 terms of the arithmetic sequence 6, 10, 14, etc. Here the sequence is 6, 10, 14, etc. What is the common difference? 4. Now let us find the difference between first term and 20 first term. We know that is 20 times common difference, or 20 into 4, that is 80. Now what is the difference between 22nd term and second term? That is also 20 times b, or 80. In the same way, the difference between 23rd term and third term is also 80. The difference between 24th term and 4th term is also 80. And the difference between 40th term and 20th term is also 80. That is, we are taking first 20 terms and the next 20 terms. So the difference between terms at the corresponding positions is always 80. That is, difference between 21st term and first term is 80. Difference between 22nd term and second term is again 80. And the difference between these two terms is 80. And the difference between the last two terms is also 80. That means when you take only one term, the difference is 80. If you take sum of two terms, the difference is 80 plus 80. If you take sum of three terms, the difference is 80 plus 80 plus 80. When you take sum of 20 terms, the difference is 20 times 80. That is, difference of first 20 and next 20 terms is 20 times 80. That is 1600. Now the third problem, calculate the difference between the sums of first 20 terms of the arithmetic sequences 6, 10, 14, etc. and 15, 19, 23, etc. There are two sequences here. What is the common difference of the first sequence? That is 4. And what is the common difference of the second sequence? That's also 4. So these are two sequences having the same common difference. Now let us find the difference between the first terms. That is 15 minus 6, or 9. What is the difference between the second terms? 19 minus 10, that's also 9. What is the difference between the third terms? 23 minus 14, that's also 9. Now since the common differences are same and the difference between the first term is 9, the difference between the terms at corresponding position is always 9. That is, the difference between fourth terms is 9, the difference between the fifth terms is 9, and difference between the 20th terms is also 9. So when we take sum of 20 terms, the difference between the sums is 20 times 9, that is 180. Today, let us do the remaining problems from page number 35. The fourth problem is find the sum of all 3-digit numbers which are multiples of 9. First of all, we need to find all 3-digit numbers which are multiples of 9. We know it is an arithmetic sequence with common difference 9. Which is the first term? We know 99 is a multiple of 9, but there are only 2 digits. To get the next term, we have to add 9 to it. And then the first term is 108. That is, 108 is the first 3-digit number which is a multiple of 9. Now we have to find the last term. Let us look at the last 3-digit number, that is 999. And that's a multiple of 9. So the last term is 999. And we know this is an arithmetic sequence with common difference 9. Now to find the sum of all these numbers, we need to find number of numbers of the sequence. How can we find the number of terms of a sequence? There are different ways. We know the common difference is term difference by position difference. Here the common difference is 9 and last term is 999 and first term is 108. Subtracting, we get 9 equal to 891 by n minus 1. We can take n minus 1 on this side. We get 9 into n minus 1 equal to 891. Now we can take 9 on this side. We will get n minus 1 equal to 891 by 9. And dividing, we will get n minus 1 equal to 99. Taking minus 1 on this side, we get n equal to 100. That means there are 100 terms in this arithmetic sequence. Another way to find the number of terms is, here 999 is 111 into 9. That is 1/11th multiple of 9. Now what about 108? It is 12th multiple of 9. That is 12 into 9. That means there are 11 multiples of 9 which are either 2 digits or 1 digit. So let us subtract all those multiples. Then we will get number of multiples of 9 which have 3 digits. That is, this is the 1/11th multiple. From that we have to subtract 11 multiples because they are of either 2 digits or 1 digit. So 111 minus 11, we get 100. So once again we get number of terms is 100. Some other people use the equation n is equal to xn minus x1 by d plus 1. If you know the equation, that also can be used. Now whatever it be, number of terms is 100. So sum is equal to n by 2 into first term plus last term, that is 100 by 2 into 108 plus 999. 108 plus 999 is 1107 and 100 by 2 is 50. Multiplying, we will get 55,350. Now the fifth problem. The expressions for the sum of n terms of some arithmetic sequences are given below. Find the expression of the nth term of each. Let us take one by one. The first one is n square plus 2n. We need to find the expression for nth term of this sequence. To find nth term, we need first term and common difference. We know the first term is the sum of the coefficients of n square and n, that is 1 plus 2, that's equal to 3. And the coefficient of n square is half the common difference. Here the coefficient of n square is 1, that is half the common difference, means common difference equal to 2. Now we can find the nth term, that is equal to dn plus f minus d. Replacing the values, we will get 2n plus 3 minus 2. 3 minus 2 is 1. So we get 2n plus 1. This is the expression for nth term of this sequence. Now the second part, 2n square plus n. First term is 2 plus 1, that is equal to 3. Common difference is 2 into 2, that is equal to 4. Now nth term is dn plus f minus d, that is 4n plus 3 minus 4. 3 minus 4 is minus 1, so we can write it as 4n minus 1. And the third part, n square minus 2n. First term is 1 minus 2, that's equal to minus 1. Common difference is 2 times 1, that's equal to 2. Now nth term is dn plus f minus d, that is 2n plus minus 1 minus 2. Minus 1 minus 2 is minus 3, so we can write it as 2n minus 3. Now fourth part, 2n square minus n. First term is 2 minus 1, that's equal to 1. Common difference is 2 into 2, that's equal to 4. So nth term is dn plus f minus d, that is 4n plus 1 minus 4. 1 minus 4 is minus 3, so we can write it as 4n minus 3. Now the fifth part, n square minus n. First term is 1 minus 1, that's equal to 0. Common difference is 2 into 1, that's equal to 2. So nth term is dn plus f minus d, that is 2n plus 0 minus 2, that is 2n minus 2. Now the next problem, calculate in head the sums of the following arithmetic sequences. Let us take one by one. You know how to find the sum of terms of an arithmetic sequence, but here we have to do it in our head in a simplified way. So let me take the first part, 51 plus 52 plus 53 plus up to 70. Here the first number is 50 plus 1, second is 50 plus 2, next is 50 plus 3, and the last is 50 plus 20. So there are 20 terms, and in each term there is 50. So let us take all the 50s together. How many 50s are there? 20 50s, or we can write 50 into 20. Here we have taken 50s from all these terms. What remains now? 1 plus 2 plus 3 up to 20. Now 50 into 20 is 1000, and we know this is sum of first 20 natural numbers, that is 20 into 21 by 2, or 10 into 21, that is 210. Adding we get 1210. This way you can calculate this in your mind itself. Now the second part, 1 and a half plus 2 and a half plus up to 12 and a half. Let me take first 13 odd numbers, 1 plus 3 plus 5 plus up to 25. We know sum of first 13 odd numbers is 13 square. How can we understand there are 13 odd numbers? When we take 10 natural numbers, 5 of them are even numbers and 5 of them are odd numbers. When we take 20 natural numbers, 10 of them are even and 10 of them are odd. So let us look at the next even number. 26 is the next even number. Then half of them are odd and half of them are even. When we take up to 26, 13 of them are odd and 13 of them are even. We know 26 is even. So when we take up to 25, there are 13 odd numbers and 12 even numbers. So anyway, sum of these odd numbers is 13 square or 169. Now let me take 1 on the other side. So we get 3 plus 5 plus up to 25 equal to 169 minus 1 or 168. Now look at our problem. 1 and a half is half of 3. 2 and a half is half of 5. Lastly, 12 and a half, that is half of 25. So we need to find half of this sum. So let us take half of this sum. Then we have to find half of 168. That is half into 3 plus 5 plus 7 plus up to 25 equal to half into 168. This is 1 and a half plus 2 and a half plus 3 and a half up to 12 and a half. And this is 84. That means 1 and a half plus 2 and a half plus etc. plus 12 and a half equal to 84. Now the third part, let me take sum of first 25 natural numbers. We know it is 25 into 26 by 2, or that is equal to 25 into 13. that is equal to 325. Now look at our problem. Half is half of 1. 1 is half of 2. 1 and half is half of 3. And lastly 12 and half is half of 25. That means we have to find half of this sum. Half into 1 plus 2 plus 3 plus up to 25 equal to half into 325. This is half plus 1 plus 1 and half plus 2 plus etc. plus 12 and half. And half of this is 162 and half. Prove that the sum of any number of terms of the arithmetic sequence 16, 24, 32 starting from the first added to 9 gives a perfect square. Let us check it. 16 plus 9 is 25. It is a perfect square. Now add the first two numbers. 16 plus 24. That is 40. 40 plus 9 is 49. Again a perfect square. Now let us add all these three numbers. 16 plus 24 is 40. Plus 32 is 72. Plus 9 is 81. Again a perfect square. We have to prove that the sum of any number of terms of the sequence starting from the first added to 9 gives a perfect square. How can we take sum of any number of terms? For that, let us find sum of n terms. And when we give different values for n, we get sum of all terms starting from first. So first of all, let us find sum of n terms, which is the first term here 16. And what's the common difference? 8. Now let us find nth term. Nth term is dn plus f minus d. That is 8n plus 16 minus 8. 16 minus 8 is 8. So this can be written as 8n plus 8. So we got the last term or nth term. Now let us find the sum. Sum is equal to n by 2 into first term plus last term. That is n by 2 into 16 plus 8n plus 8. Now 16 plus 8 is 24. So we can write it as n by 2 into 8n plus 24. Now 8n is 2 into 4n and 24 is 2 into 12. So 2 can be taken outside and we can write it as n by 2 into 4n plus 12. Now 2 and 2 can be simplified and we get n into 4n plus 12. Multiplying we get 4n square plus 12n. So this is the sum of n terms of the sequence. Now we have to add 9 to this and we have to prove that it is a perfect square. So let us add 9 to it. Sum of n terms is 4n square plus 12n and we have added 9 to it. Now 4n square is a perfect square. It is the square of 2n. So we can write it as 2n square and 9 is a perfect square. It is the square of 3. Now the middle term, that is 2 into 2n into 3. Now we know a plus b whole square equal to a square plus 2ab plus b square, or we can write a square plus 2ab plus b square as a plus b whole square. That means there are 3 terms. Here also you can see 3 terms. There are 2 perfect squares, a square and b square. Here also you can see 2 perfect squares, 2n whole square and 3 square. Now what about the middle term? Take the square root a and square root b, multiply it, double it. The same way multiply 2n and 3, that is 6n, double it, that is 12n. So this can be written as 2n plus 3 whole square. That means sum of n terms plus 9 is a perfect square. 2n plus 3 whole square means it is the square of 2n plus 3. So it is always a perfect square. When we give different values for n, we will get different sums, but always it will be a perfect square because it is of the form 2n plus 3 whole square. So we can say sum of any number of terms of this sequence starting from the first added to 9 gives a perfect square. Now the 8th problem, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Write the next two lines of the pattern above. Write the first and last numbers of the 10th line. Find the sum of all the numbers in the first 10 lines. First of all, we need to write the next two lines. See, these are all natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. If you take all the terms together, it is the sequence of natural numbers. And in the first line, there is only one number. In the second line, there are two numbers. In the third line, there are three numbers. In the fourth line, there are four numbers. And therefore, in the fifth line, we need to write the next five natural numbers. That is 11, 12, 13, 14, 15. And in the sixth line, we need to write the next six natural numbers. That is 16, 17, 18, 19, 20 and 21. Now the second part, write the first and last numbers of the 10th line. Up to 9th line, how many numbers are there? In the first line, there is only one number. In the second line, there are two numbers. In the third line, there are three numbers. And like that, in the 9th line, there are 9 numbers. So the total number of numbers up to 9th line is 1 plus 2 plus 3 plus up to 9. And we know this is sum of first 9 natural numbers, that is 9 into 10 by 2 or 9 into 5, that is equal to 45. So when we consider up to the 9th line, there are 45 numbers. So the first number of the 10th line is the 46th number of this sequence or 46th term of the sequence. We are taking natural numbers starting from 1. So 46th term means it is actually 46th natural number and that is 46. So the first number of 10th line is 46. Now in the 10th line there are 10 numbers. 46 is the first number in the 10th line. Means there are 9 more numbers. So the last number is 46 plus 9. That is 55. Now we need to find the sum of all numbers in the first 10 lines. In the first 10 line means there are a total of 55 numbers. 1 in the first line, 2 in the second line and 10 in the last line. So we have to find 1 plus 2 plus 3 plus up to 55. That means sum of first 55 natural numbers. We know sum of natural numbers is n into n plus 1 by 2. Here we have to find sum of 55 natural numbers. That is 55 into 56 by 2 or 55 into 28. Multiplying we get 1540. Now the ninth problem. 4, 7, 10, 13, 16, 19, 22, 25, 28, 31. Write the next two lines of the pattern above. Calculate the first and last terms of the 20th line. First of all, we have to write the next two lines. Here we can see a sequence with first term 4 and common difference 3. And in the first line, there is only one number. Second line, there are two numbers. And third line, there are three numbers. And fourth line, there are four numbers. And in the fifth line, there will be 5 numbers. So we have to write the next 5 numbers of this sequence. The common difference is 3 and the last term of the fourth line is 31. So we can write the next 5 numbers as 34, 37, 40, 43, 46. Now we need to write the next 6 terms of the sequence in the next line. That is 49, 52, 55, 58, 61 and 64. Now we need to calculate the first and the last terms of the 20th line. We know in the first line there is only one number, second line there are two numbers, third line there are three numbers, and in the 20th line there will be 20 numbers. Up to the 90th line, how many numbers are there? In the first line 1, second line 2, third line 3, and 19th line 19. So the number of numbers up to 19th line is 1 plus 2 plus 3 plus up to 19. This is sum of first 19 natural numbers, that is 19 into 20 by 2. 20 by 2 is 10 and 19 into 10 is 190. So up to the 19th line there are 190 terms. That means the first term of the 20th line is the 191st term of the given sequence. So let us find the 191st term of the sequence, that is dn plus f minus d. Here d is 3 and n is 191. So we can write 3 into 191 plus first term 4 minus 3. Multiplying and subtracting, we can write 573 plus 1 or 574. That is, the first number of the 20th line is 574. Now there are 20 terms in the 20th line. 574 is the first number, or 191st term is the first term of the 20th line. There are 19 more terms. That means the last number of the 20th line is the 2/10th term of the sequence. That is dn plus f minus d, or 3 into 210 plus 4 minus 3. That is 630 plus 1 or 631. That is the last number of the 20th line is 631. Today we have done some problems related to sum of arithmetic sequences, and that completes the first chapter. Once again, revise the chapter thoroughly and clear your doubts. Don't forget to revise at regular intervals. In the next video, we will discuss previous questions from this chapter so that you can understand how the questions are for the examinations. Let me know your suggestions and feedback through the comment box. Stay home, stay safe. Bye.